Sinovoltaics' new platform launch. So last week we launched PV Lab Test Advisor, a free web-based tool that helps developers, IPPs, and DPCs build project-specific reliability testing scopes for their solar projects.
Having good contracts and warranties will not secure 100% the potential loss of revenues. On top of that, asset management scope is not standard. It's usually ranging between pure
at the site conditions, not just at the perfect factory conditions. So focusing on that, of course, is vital as well to prove that the system is working as it should. And
compliance and performance tracking. So all these setups are mainly driven by the contractual specifications. For example, in the battery data storage strategy, long-term storage in opposition with monthly raw data storage.
The real state of charge is something else than the BMS is saying. And these kind of small unnoticed things, they gradually become issues, and later on they...
Hello everyone, and thank you for joining us today. Welcome to this Sinovoltaics webinar hosted in collaboration with AnarFlex on BESS asset management and optimization for long-term operational performance. My name is Sinovoltaics, and I'll be moderating today's session. Battery storage is moving fast from a niche technology to a core part of the energy mix, but the conversation is shifting. It's no longer just about getting projects built, it's about what happens after commercial operation date. Have assets perform over 10, 15 or 20 years, how they're managed, how warranties hold up, and how owners protect the returns. That's what we'll be digging into today. Before I introduce our guest speakers, a few quick notes. This session will run for about an hour. Our speakers will share their perspectives and we'll have time for Q&A at the end of the webinar. Please drop your questions in the chat box on the right-hand side of your screen, and we'll get to as many questions as we can at the end of this webinar. Please know that this webinar is being recorded and will be uploaded on Sinovoltaics' YouTube channel. If you don't want to miss the newest content updates on YouTube, don't forget to subscribe to our channel. So now, let me introduce the stars of today's webinar. I'm really glad to have Maxime Robin. Maxime, I invite you to join me on the stage. From AnarFlex team, co-founder and associate director. Good to see you.
Hello, everybody.
Maxime leads engineering studies for large infrastructure projects across all technical disciplines, working closely with owners, contractors, and operators. At AnarFlex, he has delivered several large-scale BESS projects in France, ranging from 90 to 200 megawatt, covering development, procurement, and execution. He brings end-to-end BESS expertise across procurement, integration, contractual management, and feasibility and strategic studies. Next guest speaker from AnarFlex company is Eduard Volstek. Good to have you, Eduard, and good to see you.
Yes, hi everyone. Thanks for
Eduard has 7 years of experience as technical asset manager specialized in battery energy storage systems. He has overseen operational BESS assets from 1 megawatt to 100 megawatts across Europe, the US, and Chile, working with NW Group and Grenergy. His expertise spans performance specifications, testing and commissioning, O&M, and technical asset management. And finally, a third speaker in today's webinar is my dear colleague, Ville Julin. Ville, good to see you.
Hi, everybody.
Ville is an energy storage expert with a master's degree in electrical engineering. At Sinovoltaics, he advises clients on PV and BESS quality control and supplier contract negotiations. Ville also brings hands-on experience across the Nordics and Latin America in BESS early stage development, hybrid projects, and revenue analysis, with a technical foundation in virtual power plant systems and power electronics R&D. So we have a really strong list of speakers today. And before I hand over the virtual microphone to AnarFlex team, let me quickly introduce Sinovoltaics to those who don't know us. So Sinovoltaics is a quality assurance and engineering services firm working with developers, IPPs, and investors across the solar and storage industry. For over 17 years, we've helped clients de-risk their projects through factory audits, supply due diligence, production monitoring, and technical advisory with teams based in Asia, Europe, and the Americas. And the last point I want to mention is Sinovoltaics' new platform launch. So last week we launched PV Lab Test Advisor, a free web-based tool that helps developers, IPPs, and DPCs build project-specific reliability testing scopes for their solar projects. The thinking behind it is simple. The industry has gotten used to copy-pasting the same testing scope from one project to the next, but that doesn't really reflect how different the actual risks are between, say, a project in Atacama Desert and one in northern Germany. So climate, technology choice, and site conditions all change what you should be testing for. The tool takes a few project-specific inputs and generates a tailored testing scope that you can download as a PDF report. It sits within our zero-risk solar framework and is free to use. I'll pop a link to this platform in the chat box, so you can test it out. And right now, I want to hand over the virtual microphone to Enerflex team. Maxim, over to you.
Thank you, Rosa. Just a few words about Enerflex before we get into the core of the presentation. So we are a consulting and engineering company dedicated to energy storage projects. We work for developers, project owners, investors throughout all the life cycle of the project, from early stage development down to commissioning and operation phases, including permitting, support, due diligences, procurement, and owner engineering. We've been operating since 2024, and we have been involved so far in about 5 gigawatt-hour of BESS projects in 8 different countries, and so far we totalize 1.7 gigawatt-hour of projects that are right now in operation. In the last 2 years, we have witnessed the fact that doing asset management for BESS is not an easy task. We are facing challenges that are quite new in the industry compared to classical renewables. First of all, from technical point of view, we are dealing with very new products that are constantly evolving: the densities, C rates, sodium-ion, cooling, inverter technologies, fire safety, regulation, etc. Everything is changing very fast in this industry, as you all know. And obviously, the data available to track, understand, and predict the behavior of the system is quite limited at the moment. And this is something, this is a fact that we have to deal with as asset manager. It's also to be noted that BESS is not a single product, but it's a combination and integration of many subsystems that have to work together, to interface together, and that have to deliver a global and single performance as a whole. It's also important to note that compared to traditional renewables, BESS is particularly sensitive to control and data monitoring, and we'll see it a bit later in the presentation. Second point, second particularity, I would say, of the BESS is its contractual complexity. We have witnessed also how difficult is it to track and measure the gaps between what happens in the real life and the contract KPIs, which is essential to enforce the contract obligation, right? So having good contracts and warranties will not secure 100% the potential loss of revenues. On top of that, asset management scope is not standard. It's usually ranging between pure financial monitoring to O&M direct management, sometimes a bit of both, part of both. And this configuration phase change during project lifetime. For example, some asset manager wants to take over some activity, maintenance, for example, after a few years of operation. And even though when the scope is clear between all the parties, it requires to have very smooth workflow and interface definition between all the parties involved, including also the aggregator or I would say the market representative. The third aspect that makes BESS very specific is the revenues. As most of you know, I guess, a majority of the revenues today are based on frequency regulation markets, at least in France and most of European countries. But with the saturation of those markets in the next years, the revenue generation will shift to be mostly based on spot market, day ahead, intradays. And we know that those markets are very volatile. So to capture the value of those markets, batteries will have to exchange large volume of energy at several time slots during the day, and thus require the battery to be fully operational with maximum capacity during those time slots. This means that downtime, degradation, generates direct and increasing risk of losses and potential penalties for the project. So this being said, how to address those challenges and ensure, even optimize, long-term operational performance? We believe that asset managers have to put in place strong process from the lower project level, means at the site raw data, up to KPIs visualization and high-level decision. And that this process, we believe that this process could be formalized into 5 modules that we are going to develop for you today. I let Edouard take over from here.
Yes, thank you, Maxime. So yes, in order to better address these challenges explained by Maxime, and to optimize long-term operational performance, a balanced mix of human expertise and appropriate tools, tailored tools, is essential. So the first layer of this asset management environment, I would say, represented by the first module of the asset management rack in the picture on the left, is the on-site data setup and acquisition. So what are the main messages here? Define early, align clearly. So the objective is to define at an earliest possible, ideally even before the contract signature, define with the client and other third parties all the data requirements. Secondly, more data, more control. So data is available for every project, but its accessibility varies a lot depending on the provider. Some providers are accustomed to give a full access to all raw operational data, from the battery system to the point of interconnection, while others follow more, let's say, a black box approach, allowing only limited and tightly controlled access to the data. Third point, capture data at the right source. So data must be collected at the appropriate level. For example, the energy measured at the point of interconnection will differ from that at the rack level, obviously. And then enable compliance and performance tracking. So all these setups are mainly driven by the contractual specifications, the client-specific requirements, and the operational activities. These basically define the precision asset manager will be able to have in their operational tools, and the ability, as well as the ability to make detailed and in-depth technical analysis. So the second module of our rack is the data transfer and organization. It is when the data is received by the data infrastructure. And then here the main messages are secure data connectivity. So all data infrastructure, including the on-site parts, must be set up in a really secured environment. Firstly, at a cybersecurity level, implementing passwords, firewalls, avoiding remote access with application as AnyDesk or TeamViewer, for example, and prioritizing secure channel, even when possible, with IP traceability. And secondly, at the communication level, basically to ensure the continuity of communication between the site and the data infrastructure. Secondly, rack data, right resolution. Here the point is to define the precision needed for the different uses. For example, for troubleshooting and alerting, higher precision, normally at 1 second or even below, is needed in comparison with the supervision and the reporting activities, where more aggregated data are commonly used. We used to see 1 minute or 5 minutes granularity, even more. Thirdly, structured data for performance and compliance. So ensure to align with OEM warranties, for example, in the battery data storage strategy, long-term storage in opposition with monthly raw data storage. And finally, long-term robustness and flexibility. So all these developments must be carried out with the understanding that these tools need to remain adaptable while ensuring long-term reliability. Now, just as an example, to give you an example of what can looks like data infrastructure for BESS asset management, here is more or less our infrastructure and Anflex infrastructure. It's probably neither the best or the worst option, but it is a type of infrastructure that is simple to implement, allows us to meet the data requirements for a BESS project, which are quite specific, and is highly adaptable. So it's a combination of tools with several functions. Basically, you can see the data reception, the long-term storage, the data configuration, the data visualization part, the code storage, and finally the whole general orchestration. So the third module of our rack, so the two first modules are really key in order to preparing and optimizing the activities of the remaining three. So the third module, the day-to-day operation management. So here, the main objectives in this part are, firstly, to minimize the number of on-site intervention in order to decrease the O&M extra cost by filtering and assessing whether an urgent on-site intervention is required or not. Secondly, to reduce response time to maximize the site availability. And thirdly, efficiently guide the field intervention technician to maximize also the performance of the project. So minimize the number of on-site intervention, reduce response time, and efficiently guide the field intervention technician to decrease the O&M extra cost, maximize the site availability, and maximize the performance of the project. So to meet these objectives, these challenges, the asset manager expertise is have to be supported by data-driven insights, precise analytic tools, and automatic alerting system, ideally supported by AI to facilitate, for example, common diagnosis. The fourth module of our rack, of our asset management rack, is the default anticipation. So indeed, anticipate failures is the best way to prevent long-term unavailabilities, allowing preventive material replacement and spare parts supply anticipation, mainly. So how can it be done? Mainly by deploying trained algorithm based on multi-sources data, diverse projects, technologies, products, markets, and so on, to identify patterns and abnormal trends. So as for example, two of the most, let's say, easily predictable faults, because the most common we are seeing in our day-to-day asset management currently, are firstly the battery internal temperature deviation or battery room temperature deviation, basically the detection of sudden or gradual and isolated or recurring deviation by comparing expected behavior under defined condition with the abnormal behavior. Second example is the sales voltage deviation. So basically voltage is relatively easy to monitor, provided that the data is accessible, obviously depending on the provider. So voltage deviation compared to other cells, or even between, can be done between racks. So it can generally be detected quite easily, both for cells and racks. So this is particularly critical given that battery modules are usually not included in the spare part inventory due to the really specific storage conditions. So making it possible to anticipate replacements within a plain and controlled timeframe. I talked about these two particular failures, defaults, but I can add also to prevent stock imbalance, internal module resistivity imbalance, specific inverters temperature deviation, and few other critical defects that may have a significant impact on the overall project performance.
Okay, thank you, Edouard. To continue with the last module of this approach, the high-level operation management, it's basically the visible part of the asset management. It is what most of the people think that is the scope of the asset management, and this is the the part that is the most exposed. What is important to understand here is that all tools, process, and expertise described in the modules previously only aim at enabling the asset manager to perform those functions. So the high-level operation management is basically the four functions that are described on the right side. The first one is the contracts management. So all the data, infrastructure, and the organization that we saw should support the good and accurate contract management, should help to activate the LDs, to manage the claims when necessary, to ensure contractual obligations are met. The second aspect is the warranties. The data is helping to monitor and enforce warranty conditions in order to protect the asset value and minimize the risk. Third point is, of course, a very important part of the asset manager is to be able to report on the assets to stakeholders and decision makers. So again, here the data infrastructure and organization that we have set up previously will help to provide transparent data-driven reporting. Fourth aspect is the financial awareness. It consists here of understanding the financial impacts of all preventive and corrective actions on the battery and control them better. For example, plan unavailabilities as much as possible to limit the impacts on the revenues, avoiding to have the battery off-grid during market peak hours or specific period in the year. It is the purpose here is to make connection between technical parameters and financial KPIs. Now, speaking of KPIs, here just a quick example of how we visualize those data. So Edouard developed, I would say, the left part of the diagram above here, which is the data infrastructure and data flow. Here we are talking rather about the right side of the diagram, which is visualization and reporting. So there are plenty of tools that can be developed and used by asset managers. Here it's two examples. On the left side is a dashboard for O&M support and precise fault diagnosis that we've been using. And on the right side is a dashboard rather for high-level supervision, decision-making, etc. So those dashboards are powered with algorithms developed by Interflex. It allows to do some automatization of alerting, anticipate failures, optimize maintenance planning, etc. Of course, there are many tools and dashboards that can be developed depending on the use, depending on how the asset managers want to work and how necessary they need to complement their skills by the tools. As Edouard has said in introduction, asset management is always a combination of human expertise and customized tools. Last slide, sorry, of our presentation, it's about the future. We explained the challenges that today BESS asset managers are facing, but it's also very important to understand and anticipate the challenges of tomorrow. The first one is the market. We know that BESS are facing higher and higher exposure to spot market volatility. So it's important for the asset manager to understand that and adjust valuation strategy accordingly, and be able all the time to challenge aggregators about the way the asset is being valued on the market. The second point is the contract. We saw how important it is to have secured long-term commitment with the EPC, with the suppliers, with the O&M, with the aggregator. But it's also very important to have to keep flexibility for configuration change. BESS projects are here for 15 years, 20 years, sometimes more. We know that there will be some changes, whether technically, whether organizationally. For example, asset manager want sometimes to take over, or actually to let some part of the scope to a third party. So contracts have to be set up for that. The third point is the technology. We acknowledge the fact that there are continuous technological advancements improving battery performance, safety, and lifespan. We talk a lot about innovation in battery chemistry, energy density, etc. But for asset management, we believe that digitalization is key, will be key to improve monitoring, control, and optimization capabilities. So asset managers will have to integrate that for sure. And the last point is the asset lifetime extension. It's essential to maintain and enhance system performance over the time. Can be done with different strategies, repowering, augmentation, but also optimizations of the control command. This is for the purpose of extending, of course, the lifetime, but also sometimes it's a matter of adapting to evolving requirements and to optimize during the course of the project the overall return on investment. So that's it for us. Thank you very much. I will let Raza and Ville take over from here.
Thank you, Maxime, and thank you, Edouard, for an interesting one. While you were presenting, we kept receiving questions. I think it also signalizes the importance of the topic. Ville, I would like to invite you on the stage to continue the presentation on today's topic, and we'll be handling the Q&A session after Ville's presentation. Over to you, Ville.
Yeah, thank you, Raza. And thank you, Maxime and Edward, for the very good presentation. So I'll be also covering long-term BESS performance, but from a slightly different perspective on how focusing on quality from the very beginning will play a big role on the future performance of the battery asset. So when I think of battery or BESS performance, I try to divide it into two groups. So you can think of noticeable performance of the system, like getting alarms, knowing the availability of the system, or getting real-time values of the system, like energy, temperatures, voltages, currents, and so on. But then there's also a lot of things that often go unnoticed, as NRFlex was also explaining, that are difficult to read or interpret. So these are often like temperature trends or long-term trends, round-trip efficiency, how the voltages are behaving, state of charge of the system drifting, meaning that the real state of charge is something else than the BMS is saying. And these kind of small unnoticed things, they gradually become issues, and later on they can become these kind of noticeable performance topics, like the system is no longer available, or you cannot get the right amount of energy out, or you just have a short circuit and get an alarm. So these kind of things, both of these performance topics start from the same place, from the design of the system and also from the factory floor. So in my opinion, you should optimize the system only after you have a functioning system, after a strong basis. So how to achieve that kind of strong basis is threefold. So of course you start with the contracts, and when you actually start with the manufacturing of the battery, inverter, transformer, so on, that's where these kind of faults or underperformance issues can start with. So what we do, for example, with batteries, is that we are starting to do production supervision, monitoring, meaning that when the manufacturer is manufacturing the batteries, installing the modules into racks, containers, we are there to see every step of that manufacturing process, to see that no shortcuts are taken, everything is smoothly installed, and thus preventing any mistakes before the product reaches the end of line. And there's often a lot of very small things that can seem trivial and not relevant at the factory stage, like some tolerances being slightly off, or some machines are not being calibrated that are used to manufacture the equipment. And that's most likely true that in the very beginning it doesn't really matter, but then when the asset is operating 5, 10, 15 years, then those small tolerances start stacking up and then creating bigger differences between the components and assets. So that's the first step that we do. Secondly, the normal way is also to do a factory acceptance testing. So for example, batteries, you do visual inspection, safety, electrical, mechanical testing, and also a performance test, meaning a full charge discharge cycle to see if the battery container is fulfilling its contractual performance. like energy capacity, round trip efficiency, power, and so on. Since that test is often only it's only on the container level, but you still have subcomponents like modules and racks inside of the container. We use this Essential software to analyze also each and every one of those subcomponents during the FAT. And the idea there is that with FAT and this analysis in general is that when we find these issues during at the factory floor, it's going to be much quicker to replace and cheaper and easier to replace and fix these issues than at the site when you need to do troubleshooting and use spare parts or send an engineer from China to the site. So that's the second step. Even though we would do a perfect FAT for all the components at the factories, you still need to do site acceptance testing. So to verify that also the components, subsystems, and the whole system is operating at the site conditions, not just at the perfect factory conditions. So focusing on that, of course, is vital as well to prove that the system is working as it should. And one option there is also to do this Essential for the batteries during site acceptance testing, since in many cases we try to push that we can do one like FAT and this analysis for all of the containers at the factory, which would be ideal. But if you cannot do all of them at the factory, then we can do like a hybrid analysis for the rest of the containers at the site. And using these three pillars of quality checks and inspections, you will get your system faster in operation, since you eliminate most of the issues, be it like a small baby issue or like real performance issue that was found during the inspections. And also, especially with this Essential, when you can verify that also not just the container level will be working, but also the racks and the modules are working as it should be, then you can really say that you have the contracted performance of the system. And lastly, a couple examples what we find on the field, on the factories. So one very common thing we find is the fire safety system not working properly. It can be sensors that are not working, or they are not installed properly, or then they can work on a software level, but then using real signals like heat, smoke, they are not working. Secondly, high temperature differences. NRFlex was also highlighting this. So this is something which is sometimes difficult to implement in your contract, having a certain threshold for how big the temperature differences can be, what are the absolute temperature thresholds when performing these kind of tests. And sometimes, of course, we see that temperatures are above those thresholds. Then it means, of course, a failed test. But sometimes the temperatures are close to the threshold. It's still going to be a pass, but it's important to keep an eye on those units or containers, modules that are closer to this limit. So then you can transfer that to your O&M team to know to focus on those especially. And yeah, cell voltage imbalances we also see quite often with our software, meaning that when you charge or discharge the batteries, some of the cells will reach their threshold voltage faster than the others, and that will result in like aging differences between the cells and the modules, and also you will get less available energy out of the system, since some of them will start or stop earlier. Yeah, that's my part, and let's go to the Q&A session.
Thank you, Ville. Yeah, truly enlightening presentation. And the number that you shared, like the 25% of fire safety system not working, that also reminds me of the case I saw in the news last week from this UK-based, one of the oldest battery systems that caught fire because of a short circuit. And imagine your fire suppression and alarm systems not working in such case. So that's a disturbing number, I think. Yeah, thank you, Ville. I would like to invite Maxime and Edouard back on the stage for the Q&A session. And thank you all the delegates for a really good number of questions. Let's try to answer at least some of them, but I think we should be able to answer most of them as we have a nice 20 minutes for the Q&A. So Ville, just to pick up on your presentation, you showed that the fire safety system was not working in 25% of cases checked. That's a striking number, I agree with that. What's behind it, and are these issues being caught by the O&M's own internal QC or only by independent inspections like Sinovoltaics?
Yeah, it's a good question. So I think let's say the reasons behind it are most of these kind of issues are like human related, that just some component has been wrongly installed, cables have been turned around, so to say, or there's just some bad components over there. And some of these, of course, will be found by the company or the O&M itself, but it's a very, let's say, different, it's a range of, how would I say, companies or manufacturers, factories, they have all a very different set of testing that they do for the containers. So some of them will have plenty of tests and ways of seeing these, and some of the companies will also only do like very limited testing. So then, for example, using just a signal on a laptop to simulate a problem instead of a real like smoke. So that's why these kind of things often slip through their hands, and then we spot them during our inspections.
Yeah, and it also, if I may add, if it's not included, some tests or the scope of the tests are not included in your contract, well, the manufacturer is not obliged to do these tests. So it's also a contract optimization, a very important process. Thank you, Ville. Now let's turn to Anarflex team. A general question about the software itself. Is your software locally hosted or cloud-based? Will it require local hardware integration? Whoever wants to pick up this one.
I will take this one. The software is generally part of it cloud-based. I mean the long-term storage part, we'll say. And then we have also, yes, a part of the software locally hosted, but this is the minor part. And local hardware integration. So in order to collect the data, we are currently using several systems, both with implementing on-site hardware system, really simple and really easy to implement, and by connecting directly with the on-site data logger in order to collect in our infrastructure directly from the on-site equipment.
All right, thank you. A question from Erwan, also to NRFlex team. Can the tool calculate equipment availability?
I will say yes. So we are able to calculate obviously the equipment availability, and it will depend on what availability will be needed. Basically, normally we are calculating several availabilities. It could be the grid availability, the overall project availability, even the rack level availability could be useful in order to calculate really precise availability. So yes, we are used to set up our equipment in order to calculate all the relevant availability of the project.
Yeah, I will just add that if the question is about the contractual availability, as we have explained during the presentation, we will set up all the data process and organization also in order to have the good KPIs for the contract management. So definitely one of the purpose of our asset management service is to be able to properly manage the contract, and we know how important is the availability parameter in the contract management. So definitely, and the possibility to have an independent measurement or calculation of this availability is actually key in the BESS asset management, because otherwise we are depending on I would say third-party parameters, sometimes with interpretation and way to measure and calculate, which is exactly what we want to avoid by deploying an independent asset management system.
Thank you, Maxime. Another question to your team again. So Julian is saying that he assumes that knowledge is limited so far, but do you also observe failures due to external factors at the location of the BESS system?
So yes, obviously the main external factor that impact the BESS system is the temperature, and this component have to be taken in consideration really early in the development phase, and generally it is the case. So in main of the project, we are seeing if the battery are developing in north of Europe, you will have different temperature regulation system than batteries developed in Texas, for example. So this is the main external factor, and I will say another external factor to the BESS system will be the grid himself. So some grid compartment can affect the BESS system and declare some failures of the equipment. Yes.
Mm-hmm. Okay, thank you, Eduard. Another one for you from Laura Sophie. How should we as an EPC handle long-term service agreements? We don't want to be tied to the manufacturer for 15 years. What would be your advice?
Okay, first of all, it's a very wide question that we'll be pleased to discuss if we had more time. But if I trying to be short on that, how to do it. First, it depends what type of company you want to be, because we don't improvise in this activity. So basically, if you want to take over from the manufacturer and to actually do O&M by yourself, it requires expertise in-house, but also that you can find through partners. It requires a clear organization in your company and even a company strategy around that. So for me, the first question is, do you want to do that? Do you want to be like that? It's also, so basically, yeah, the expertise and the organization you will put around that is key. and necessary. Second aspect, important as well, is the financial robustness, because you will need to hold the guarantees of the product facing the client. So you need to have the capacity financially to do that. And there are probably other aspects that the question is quite large, but I would say at first glance, this would be my answer, is organization, expertise, and financial robustness.
Thank you, Maxime. Another one for you from Bjorn. Does Anarflex offer a service to assist companies with permitting processes, such as those under the Federal Emission Control Act in Germany?
At the moment, we are developing asset management in Germany. However, we are not yet active into development support in Germany, but we have partners who can help doing that, and even ourselves, we are considering doing it. But at the moment, we don't. So depending on the context, we can discuss and see maybe how we can support.
Okay, thank you. Another one for you from Beryl. It's actually two questions. So you mentioned that data acquisition strategy should be defined from the earliest project stages. In practice, how often do you see owners get this right at contract stage? And what's the most common mistake you see in the contract specifications? And we can take the second question after you address the first part.
Well, yeah, the first question is very relevant. It's actually the question we've been asking also ourselves since day one. So to answer, no, we don't see very often owners to get this right at the contract stage. Usually, it has to be specified very early in the RFP. When you select a supplier, when you select an architect as well, because it depends also on the way you want to procure the project. So from the procurement strategy, it has to be sought. It has to be properly written in the specification. It has to be discussed and I would say challenged during the contract negotiation, because sometimes this part is considered as a bit as secondary. We think first, okay, I want to negotiate the price of my batteries and data accessibility and control commands and so on. This is, I would say, not critical. So we strongly recommend to have it done and I would say square before contract signature. And for that, it requires to have the expertise also at this moment of the process to do it right from RFP specifications. And the second question about the remuneration, how does it change what an asset manager should be monitoring day to day? The first point is, what is critical when we will be on the spot market is the usable energy and it's the capability to monitor it. Because when we are on the frequency regulation, we not having the full energy available is not doesn't have too much consequences. But when we are on the spot market, any percentage or any megawatt hour of loss of usable energy is revenues that cannot be obtained. So capability to monitor usable energy in operation is I would say the most important. And the second aspect also is the battery is going to operate in a different way with full power cycles and which is going to trigger more thermal effects. So more constraint on the battery that needs to be as well anticipated and monitored, particularly when the battery is going to be under arbitrage compared to frequency regulation. But again, those are the two things that comes to my mind. There are probably other points that can be developed.
Thank you, Maxim. Another one for you, and then I have a question to Ville. So how does your asset management approach differ from the battery data analytics companies like Accure and Twice?
So this is a good question. Yes, it's a good question. In fact, these are company that are provided some really good software to integrate in the all asset management services, and to be able to anticipate failures, to be able to monitor KPIs. But this is a part of asset management. Our approach is using this type of tools. In our case, we are developing our own tools in order to support the clients, and then offer the asset management expertise services in order to use these tools and to do basically the day-to-day asset management services. So the main difference is that these companies are providing softwares when we are providing this type of software, also customized and tailored, and we are using it and using our expertise in order to use these tools the best way we can.
Yeah. Just to summarize and complement is we are, to make it clear here, we are not selling a tool, and this is a different business model here compared to the company you described. We believe the role of the asset management starts from the specification of the contract, and it goes until and through commissioning and all the way down to the operation. So this requires at every stage of the process expertise, setting up things for the project. You may have the best tool in the world if you don't have your data accessible, and if your supplier says my contract allows me to do it, you're stuck, and you may have a very nice tool. If you have a very nice tool but you don't have I would say the expertise to understand and set up the data that the tool or the information that the tool is going to render, you will not be able to detect sometimes and understand the actions to be done, also to correct and to anticipate potential problems. So it's really a holistic approach, which is really based on tool, but with a lot of expertise throughout all the process. And I would say this is the main difference.
Thank you, Maxim. Ville, a rhetorical question rather, but maybe you'll have a comment on this one. How can you, a comment from Chris, how can you talk about zero risk working with lithium batteries that carry a risk of fire when some of the safety systems fail or performs incorrectly? We need batteries that are intrinsically safe, for example, that do not need all these external safety systems. Is it possible even?
Yeah, I don't think it's possible. You have chemistries, you have you have power, energy flowing through, and equipment. It can be a battery, it can be an inverter. Anything can catch fire and have their own safety concerns. But if you think about LFP battery, it's already an improvement from NMC. Meaning that if it catches fire, it should be limited to like one rack, one container, and inside like fire safety of a BESS consists of many, let's say, different levels. You start from the BMS that it will allow or disable the batteries if the voltage thresholds are reached, or it will detect high temperatures. It will try to cut them off. Then you have you have controls on the cell levels, module rack levels, container levels. Then you have fire safety systems there. You have EMS for the whole system, Then you have, of course, external systems as well, like the fire safety system, or then you can connect your SCADA to a local fire municipality, for example. So there's a lot of steps, and if the battery catches fire, it means that a lot of things have failed, and we try to prove by testing that these all of these levels are working. But it's only, we cannot do a test every day, so then it's up to the operators to see how these temperatures, for example, are behaving, or doing yearly regular testing and checks that everything is in place. So yeah, in a short answer, it's I don't think anything is like fail safe when you talk about like active components like batteries or, for example, inverters.
Yeah, thank you, Ville. And we come to a close of this webinar. I encourage you to reach out to our speakers and experts of today's webinar. You can see their contact details on the screen. A webinar recording will be sent to the delegates of this webinar. I will see you hopefully in the future Sinovoltaics webinars, and thank you all for such a nice set of questions. We were not able to answer all of these questions, unfortunately, but the experts will be able to follow up on these questions after the webinar. So thank you, and see you in the next future Sinovoltaics webinars. And thank you, guest speakers.
Thank you, Rosa.
Thank you all.
Thank you all. Bye-bye.
Visit sinovoltaics.com to learn more.